Welcome, everyone. This is the first in our Developer Spotlight series. So this series is to showcase proof of concepts, games, and basically anything really cool that the community and also our team have been working on. So I'm very excited to introduce our first two guests, Mihir and Chiranjeev. So if you guys want to give us a quick intro, who you are, your background in Web3, and then how you got involved with Inco.
Hey, I'm here. I'm a developer. I've been in Web3 since 2021, and I'm doing hackathons for the past 2 years. And I've won some big hackathons like E Global, and I was a finalist of two of those. And recently, I built confidential decks on using TEs, and that's how I got to know about Inco, and now I'm here working at Inco.
Awesome. Love it. Chiranjeev, why don't you introduce yourself?
Hey guys, I'm Chiranjeev. I'm a smart contract developer, and I've been building on EVM for more than 2 years now. And my whole stack, for the past 2 years, I've been working on account abstraction stack, both on zk Sync and EVM. And yeah, I have built multiple wallets for other clients, mostly on the 4337 and 757 and modular structure stacks. And yeah, I have won ETH online by ETH Global in 2023. And yeah, and about Inco. So basically, when we were creating smart accounts, I realized this problem that if we are using smart accounts for remittances, how do we hide our balances? You won't like to know how much a guy is earning, or yes. So when I was exploring those privacy stacks, I know about Inco, and next thing you know, I'm working in here.
Awesome. Well, let's get right into it. So how this works is that we'll show the front end, and then we'll kind of get into the back end and look under the hood and talk through the code. So why don't you guys introduce first of all what you guys are building or what you built?
Yeah, so me and Chiranjeev, we have decided to build a very interesting and confidential game called Mines. So this game is inspired from Stake, where you have a tile grid of, let's say, 5 by 5. So there are 25 tiles, and you just take a guess. So inside each tile, there should be a bomb or it should be a safe tile. So when you click on a tile, it decrypts and shows you whether it was a bomb or it was safe. So the more risk you take, the more you earn. So you can choose how many bombs do you want in the grid. So if you say once, so every time you get a new tile, the multiplier will increase with slightly increase. But if you have more mines, then the multiplier will be exponential and you will earn more. So that's how the game works. And you can cash out anytime. And if you lose, then you will lose your whole bet. And if you win, then you can just take out your Ethereum anytime.
So without further ado, why don't you walk us through the game?
Yeah. So hey guys, this is Mines game. This game is inspired from Mines from Stake, where you have grid and you can play. You can just turn the tiles and see if there was a bomb or not. And the more you guess, the more you win. So this game is inspired from that. So let me just give you a simple walkthrough of the application. So let me just connect my wallet. Yeah, so this is the user interface for the game. On the right side, you can see the game control. The first one is bet amount. So this is the amount that you want to bet for this game. And the more you bet, the more your chances are to get the higher returns on your investment. So the multiplier will have bigger impact on that. And here you can select the amount of bombs that you want in your grid. So we are having a 5 by 5 grid. So the maximum amount of mines that you can set is 24. So let's just do 7 for now. And let's have 0.01 Ethereum. So let's just create a new game. So right now, this is calling the factory contract to create a new game and placing all the bombs and safe tiles in an encrypted manner. Right. So we have the tiles ready. So let's just click on one tile and see if it is a bomb or a safe tile.
All right. So if it's a bomb versus a safe tile, what does that mean?
Yeah, so if it is a bomb, you lose all your bet. And if it is a safe tile, then the multiplier will increase and you will have, you can continue the game or just cash out. Yeah, so this was a safe tile. And either I can cash out right now and take away this amount of Ethereum or continue the game. And like, yeah, so the more I discover the safe tiles, the multiplier will keep on increasing, right? So, but if I encounter the bomb, then I will lose all my bet.
Oh, okay.
So yeah, so let's just try another tile.
So it's nerve-wracking.
Yeah, so it is decrypting. Yeah, this was also safe. Yeah, you can see the multiplier is increasing, and this is exponential. The more you discover the safe tiles, the multiplier will increase exponentially. So let's just do one more tile.
All right.
Yeah. So let's see if it's a safe tile or if it is a bomb. Yeah, it was a
Oh,
bomb.
no.
So we lost our bet.
All right.
So yeah, so even this will decrypt all the bombs and show like where the bombs were placed. So you can see like this were the tiles where bombs were placed.
If you not, encountered a bomb, say you had, two safe tiles and you wanted to cash out, you would just
Yeah,
cash it out through the wallet that you've connected?
yeah, you can cash out anytime. Yeah. And even you can see so it shows my statistics. I've played 19 games and my win rate is 21% and I have lost one Ethereum. So I'm not that good in this game. Yeah.
Very
So
cool.
yeah, this is it. You can create a new game and like just play.
So every time I assume you spin up a new game, it's completely randomly generated in terms of the tiles?
Yeah, it is. Like we are using ERAN to to place the bombs in an encrypted manner and random manner in the tiles. And also yeah, so we have that, and we have like 24 number of mines, like the maximum that you can get because it is a 5x5 board.
Okay. Very cool. So this is the front end of the game. So let's bring Chiranjeev back in so we can look into what the back end of this game looks like.
So for developer specific info, so when you are creating, if any EVM smart contract dev is listening to this, so whenever you are creating an encrypted smart contract, there is some design choices that we need to make sure when we use Inco. So like I'll just say in this context, let's say the mine game. So I have a factory contract which basically takes your bet amount, whatever game info you have, and just deploys a new game. So it's done up here. Yeah, create mines contract. So for each player, we calculate the whatever the maximum payout will be. If the factory has that much amount, then the new game will be created. So here it calls the mines contract. So yeah, here's what the fun part. So in the constructor itself, we actually use Inco's randomness provider. So we get a random encrypted seed. So in games like, let's say you want encryption on chain and like privacy on chain for games like this, like mines, you don't need to know where a mine is placed or like but in common smart contract case, that was not possible. But now with Inco, we can store encrypted partitions of the game. So encrypted bombs positions on the tile on the grid. So we just create a random number, encrypted random number, and store it inside a variable here, UN256. Now, when the user creates a game, it basically generates unique bomb partitions. It basically places all your uh, encrypted indexes on the 5 by 5 grid. And yeah, that's how the initial thing happens. And now each time you basically want to check if it's whatever tile you selected was a safe tile, it basically calls this function here. Yeah, is tile bomb encrypted? Okay, so whatever tile you chose, was that a bomb? Okay, so what it does is basically checks that encrypted tile position, and it compares here if it was a safe tile or if it was a bomb. Okay, so after that, it just calls a request decryption on the bombs, and basically it will ask the Inco co-validator for this tile, was it a bomb? So I just checked if the tiles the selected tile was a bomb, we just do a OR operation on all the encrypted bombs and see if the result was true. So basically, what I do here is basically whatever encrypted bombs were stored in the constructor, I run a loop through all those bombs, check if whatever tile we selected and whatever bomb is present in the array is the same. So if this condition is true, so this result is also again encrypted. It's a e-bool. So the result also is not known unless and until I allow this contract to basically decrypt if the tile selected was a bomb. So yeah, this is how it happens, and it calls this handle bomb reveal. So once you encountered a bomb, Inco co-validator will basically call this function selector over here, and you just check. Yeah, so if the bomb value was decrypted value, if it was not 0, that means it was a bomb, and it will unpack all the bomb positions present in that encrypted array. And yeah, it will just emit an invite that all bomb positions are revealed and show the user the whole scenario.
Okay. Very cool. So in terms of, the developer experience, right? Building with Inco, so building the encrypted version of this game with Inco. For those who aren't, familiar with the encrypted functions that you were talking about, how was that like in terms of building this, and how does Inco play into that in terms of being able to create these encrypted functions that before
Yeah.
with traditional Solidity you wouldn't be able to call or to create?
Yeah. So I'll talk about a unique scenario here. So let's say we didn't have Inco. Let's say imagine a universe where Inco was not present. How would you create such games, right? It was not possible basically. So it will be unfair. So you can't actually store where the bomb locations are on chain because everything is public over there. Nothing is encrypted.
Yeah.
So in that case, this random generation function helps a lot because this is encrypted. You don't even know where the bombs are placed. And only when you try to decrypt, when you select the tile, then only the decryption happens and you know, okay, this tile was the bomb. Before that, there is no way to know that if this tile was a bomb or not. But let's say if Inco was not there, you can just check the smart contract on chain when it was created and see where all the bombs are placed, right? So functions like this help bring on-chain games where privacy is needed, let's say blackjack, mines, minesweeper, and yeah, all the card games that you play on normal web2 infra, let's say on stake.com. And we can bring all those stake games in here like Plinko and all with this infra.
You're writing Solidity code as you would before. You don't have to learn a new language, nothing like that.
Yeah, nothing like that. Only some design choices will be different because we can't iterate on encrypted values as so we can do in other like normal Solidity. For that, we have e.select, which basically is a condition render. So you can't basically, I'll just type an example out of here in here. So in normal Solidity, you can do something like value is true, then execute this line of code, right? But now with Inco, as the this val is encrypted, you can't do like this because Solidity won't know if the value is actually true or not. Let's say in case of e-bool. So Inco has this function over here, e.select. Okay. So basically it will just check if the condition here, e-bool, let's say I just declare, I'll just do inside a function. I just declare e-bool is bomb. Okay. So here I need to do UN256 reveal is equal to e.select is bomb. And like if this is true, then this part will be executed. This part will be considered inside this reveal function. If it was false, then this part will be executed inside this reveal function. So you can't use if blocks in here. Yeah, that's the only, I think, as far I have developed it, That's the only thing that felt different from actual Solidity. And you won't even like feel that much of a difference. You just need to follow Inco docs, and they have a very good documentation on like how do you use this kind of library functions.
All right, awesome. Well, thank you so much for giving us a kind of look into the back end. So going to bring me here back on stage. So yeah, I guess to end everything, thank you so much for walking us through what you guys have built. I guess to end, I'd like to ask one question. So what does privacy mean to you? And what does the ability to call these encrypted functions, mean in terms of development? And then where do you see kind of the Web3 space going in terms of adding privacy to the applications that we already use in blockchain?
Yeah, I think like privacy is very much needed in blockchain because like as more people adopt it, I think there's like really need of privacy because for payments also you don't want your like bank balance or like where you spend your money be publicly available to everyone, right? So that's where like I think tested use case of privacy, the payments, and there are like we can create this useful games like fun and useful games where privacy is needed. So yeah, I think privacy is very much needed in this space.
Awesome.
I have like very strong opinions on this. Like we have seen a real stablecoin adoption like for past 1 year, and more like the Stripe acquirement of Bridge.
Yeah.
Like it is a stablecoin provider cross chain, and like companies like Stripe and all are looking into the space. So obviously we will need privacy in this space, be it payroll, be it remittances, be it any kind of DeFi operations that you do. Uh, we have to like get privacy on chain because for the past 4 to 5 years the blockchains are public and all your data are visible, and the growth of AI and like your user persona that you can get from any wallet address on chain based on what DeFi actions they do or whatever money they receive, it's it's needed now. It's the need of the hour now. So we have to have private transactions on chain.
Awesome. Yeah, couldn't agree more. And that's where Inco fits in. So
Yeah.
thank you guys so much for walking us through what you've built and showing us, how things work on the back end. And yeah, this has been the first episode of our Developer Spotlight. Thank you so much for tuning in, and we'll see you next time. Bye, guys.
Yeah, see ya.